So this demonstration here is going to kind of wrap up this critical charging performance testing section. And we've been talking about, the different methods of superheat and subcooling and weighing in the refrigerant when necessary. We've also been talking about why we have to do it subcooling and why we have to do it superheat. And we know that if it's a TXV, it's going to be a subcooling. If it's superheat, it's going to be a combination of wet bulb and outdoor dry bulb, which we'll show in this demonstration. We also know that on a TXV system, we have to get the target number from the data plate. And this particular machine that I have set up here, I have a TXV and a fixed orifice, so I can switch them over. Right now, I have it set in the thermostatic expansion valve mode, so this will be a subcool test. So we'll turn it on. It'll be a little loud and noisy, but we're going to turn it on and we're going to try to get through a subcool reading, and then we're going to go and we'll switch it over to superheat, and we'll see what the superheat reading is, and then we'll compare that reading to what it actually should be. So quite a bit of things are going to be going on here, but it kind of wraps up all the stuff we've been talking about. So right now, I do have my electronic gauges hooked up. I've got the probes hooked up to the copper line set. And if you notice, I have made sure that I don't hook the probes up on top of a fitting or on top of an area where maybe they're not going to read well or get a good sense. That's important. If you put it on top of insulation or put it on top of a 90, it's just not going to be the same. So we want to get a good firm grip with these sensing probes. So this machine here is ready to go. We do have 410A refrigerant in it, and I told my gauges that's what's in there. It's not a mixed charge because we've charged it ourselves, so we know it's not. Is it a perfect charge? I don't know. Let's find out. We haven't tested it in a while. So we've got it running now. The compressor's running. We're going to start seeing some readings in the gauges, and I'm going to give it a minute. I'm not going to rush it because it takes a minute. HVAC systems, they really need about 15 to 20 minutes. We're not going to take that long, but that's what it normally would take for everything in the system to start moving around and stabilizing. Another thing to note is that an HVAC system is not up to full efficiency until about 15 minutes. So if you have an oversized system and it shuts off on minute 13 or 14, you never reach peak efficiency. So let's see what we got going. We've got 132 PSI on our low side and 235 on the high side. To see how that relates to superheat and subcool, got a 2.9 superheat reading, and we've got 4.8 on our subcool. Now, I looked on the data plate earlier, and the manufacturer said this should be a 16 on the subcool. So just going by that alone, it seems to be quite low. What we can do is we can go ahead and switch it to superheat and see how it compares when it's on its superheat mode. So what I'm going to do is we're going to let it continue to run. I'm not going to shut it off, and we'll come back to that subcooling number. But I'm going to go ahead and switch the valves over so we can quit running on the TXV and start running on the fixed orifice. So now we're going through the fixed orifice, and we're not going through the TXV. So let's see what's happening now. Now we're getting a superheat. It's getting up into the range of 9. Our subcooling's going up just a little bit, mainly because it's been running a little while. But the superheat number on the gauges means nothing if we don't know our superheat target. So we're going to get that target now. In order to get the target, I'm going to have to get a wet bulb and a dry bulb reading. And I'm going to get the wet bulb reading would come from the house. It would be inside the house. Typically, we're going to get this at the filter grill. We're going to walk over the filter. We want some unaffected wet bulb temperature. Let's see what we got there on wet bulb. Right here, we're looking at about 59 degree wet bulb. And then we have to go outside now, which we don't have to because our condenser's right here. But we would go outside to take a dry bulb at the air entering the condenser. Not on top, not at the back door, but the air at the condenser. So just give that a second, stabilize. So we're looking at 68. So we had 59 and we have 68. Now we're going to compare that. You walk over here and we'll put this slide up that shows that comparison. How do we lose that? Here we go. Right there. All right. So if we look at the chart and we see our 59 on the wet bulb, and we come in this range, and then we're at our 68, we're still in this area here. We're somewhere in the 15 superheat range, and that's today. And remember, when we're talking about superheat, that changes. Okay, let me take one more look, and I'll turn this off, and we'll talk about a little more. But right now, we're looking at head pressure 246, a subcool of 10.6, 114 on the low side, with a superheat of 12. So as far as superheat's concerned, not far away. Subcool, we'll put it back over to subcool on the TXV. Let's see what we got there. Okay, so now we're back on the TXV, and we'll see what our subcool does. Now, if you notice, you probably can't, but I'm looking at the gauges. I'm seeing changes taking place. So when we switch from one metering device to the next, we're going to get a change. We went from a fixed orifice, a fixed hole, to a thermostatic expansion valve that has the ability to open up and dump the compressor. When it does, when it dumps all this condenser, we see a change in our subcool. Our subcool number's going down. Our superheat number is also going down. And that makes sense, because as we let refrigerant out of the condenser into the evaporator, we're going to get a lower superheat number. And we're also going to get a lower subcool number because we're dumping the refrigerant. So it totally makes sense. So I know when it's running, it's a little hard to hear, but really and truly what's happening is, regardless of what metering device you're using, we have to have our proper target. And I was telling you a minute ago that on the superheat, we're looking at an indoor wet bulb, we're looking at an outdoor dry bulb, we're looking at the chart, we're comparing what that's going to be. And then we have to keep in mind that that's right now. So what if this building was the house, and the house had been off for a while, and it's got this really odd target, superheat target, because the humidity is just so high. All right, well then as I run this machine and as I start to charge it, and I take 20 or 30 minutes to check it or charge it, what's going to happen is inside that house, the humidity is going to start to lower. When the humidity lowers, we're going to get a wet bulb reading that's going to change. When that wet bulb reading changes, we're also going to get a different target for the superheat. So summarize that up. What that means is if we have a subcool target, we're getting that right off the data plate. We hit the target, we're done. If we're getting a superheat target, we hit the target, we're not done. We hit the target, we start working on it, we go back in the house, we test it again. Did we still have the same target? Most likely it's changed. And then we go back and we look at it and see where it's at. Eventually we'll get it right on the money, but it's a multi-step process. Now, that's superheat and subcool. When it comes to a day when you can't use AC and you got to weigh in the refrigerant, we're going to also look at the nameplate, and we're going to see how much refrigerant is in this condenser when it was new, and how many feet was it for. So typically, you're going to find 15 feet in here of refrigerant, and then you have to measure the line set. So if we're going to weigh this in, we would be measuring this line set all the way to the attic accurately. I mean, within 6 inches. And then we're going to take that and we're going to do that math that we've talked about earlier. So that is the demonstration. And if you follow those procedures and you get the right data and you find out what kind of metering device and then you charge accordingly, it'll work great.